to the nearest hundredth, solve this equation. So again, combine your like terms. So I'm going to move the 4 over to get negative 2. I'm going to move the cos over to get 3 cos. Divide both sides by 3 to get cos by itself. And I get cos x equals negative 2/3. We want to solve between negative pi over 3 pi over 2 and write the general solution. So the first thing we're always going to find is our reference angle. Since our angle is x, when we write our reference angle, we'd write x with a little r. We would do cos inverse of positive 2/3. Remember, reference angle is always based on an actual triangle, which has actual lengths, so we always do positive values. Okay, our question is in radians, so when I go to my calculator, I'm going to hit my mode button just to double check. I'm in radians, so that's good. And I can do cos inverse of 2/3. 0.841. So my reference angle is, and it says to the nearest hundredth, so I'll just round it to 0.84. Now, where is cos negative? So I would go to my calculator and do cos inverse of positive 2/3. Reference angles always using the positive numbers. Because if you did negative 2/3, you're going to get 2 point something, right? And that's in quadrant 2. And a reference angle is always in quadrant 1. Now, where is cos negative? Quadrant 2 and quadrant 3. So again, I'm going to go to my calculator. I'm going to store my reference angle as x. I can find quadrant 2 by doing pi minus x, and quadrant 3 by doing pi plus x. So 2.30 and 3.98. Now you're going to find you're going to do this often. I actually say it's a good idea, once you've solved that, to write beside those that those are my solutions between 0, that's 1 time around the circle, between 0 and 2 pi. In fact, you get so used to solving 1 time around the circle that you just do it naturally. We solved it in quadrant 2 and quadrant 3, between 0 and 2 pi, but then you need to look back. Is that what the question asked for? No. The question asked for negative pi over 2 to 3 pi over 2. We figured out an answer here in quadrant 2 and one in quadrant 3. Well, let's think about this. It's got negative and positive angles. Think about them separately. The negative angles go from 0 to negative pi over 2. What quadrant is that? Quadrant 4. Do we have any answers in quadrant 4? No. So that actually doesn't affect it. And here, from 0 to 3 pi over 2, can you see that that's quadrant 1, 2, and 3? And we have answers in quadrants 2 and 3. They're going to be fine. So even though the domain changed, both of those ones are okay. Man, they've made us do a lot of thinking for nothing. Okay? But then it says, then also write the general solution. So for our general solution, we take our answers from 0 to 2 pi, so 2.30 and 3.98. We're in radians, so add 2k pi. Where k is an integer. Part B. Part B is root 2 cosecant theta equals negative 5. So if you have cosecant or secant or cotangent or any trig function, again, first thing we want to do is get that trig function by itself. So if I divide both sides by root 2, I get cosecant of x is negative 5 over root 2. Then if you have one of the reciprocal functions, you can now change it by doing the reciprocal of the answer. Notice the angle stayed the same, just the answer was flipped. Root 2 over 5 on our pie plate? No. So we're going to have to use our calculator again. Start off by finding our reference angle. Sine inverse of positive root 2 over 5. This question is in degrees, so when we go to our calculator, to change our mode to degrees, and then do sine inverse of the square root of 2. Whoops. Sine inverse of the square root of 2 divided by 5. 16.4 degrees. The question said round to the nearest degree. So our reference angle is approximately 16 degrees. And then sine is negative. So which quadrants? I'm going to store that angle as x. Sine is negative in quadrants 3 and 4. So in degrees, that would be 180 plus my reference angle in quadrant 3, and 360 minus my reference angle in quadrant 4. So 196 and 344 degrees. And again, I'm going to write this note. This is solutions between 0 degrees and 360 degrees, because that's one time around. What was the domain that they gave us? They gave us from negative 180 to 180. So what is that going to be? Positive angles in quadrant 1 and 2, but negative angles in quadrants 3 and 4. Can you see that we have quadrant 3 and quadrant 4? Can you see that both of those answers are past 180? So these are both, put a line through them. And we have to write what would be coterminal with 196 degrees as a negative angle. Negative 164 degrees. Well, you could do 196 minus 360. Okay, I thought about this angle in quadrant 3. I thought about a reference angle of 16 degrees. And then I said, how would I switch the screen? There we go. How would I figure out this one? I did 180 minus 16 to get 164 and put a negative sign in front of it. How about quadrant 4? Well, that's just going to be negative 16 degrees because that's my reference angle. Things are a lot easier to figure out if you think about your reference angles. Yes? This question said to the nearest degree, so that's the only reason I did that. But you see, whenever I used my math, I stored it as x, so I kept all the decimal places. Because technically, you should only be rounding your final answers. And so when I was rounding to the nearest degree, that's how I knew it was going to be 196 and 344. But then I had to put x's through those ones anyways, because they were not in the domain. And then again, the general solution now. x is equal to, I would choose 196 degrees and 344 degrees. Your textbook would probably pick the negative ones. Plus k times 360 degrees plus k times 360 degrees, where k is an integer. Excuse me. And then plus k360 would be the same because they're coterminal. Yes. It won't, because your 180 and 360 are already to whole numbers. It makes a difference if you're in radians, though, because pi has a bunch of decimal places that it could affect your answer. You should do the special letter. It's fun. It's excited. Oh, well, don't make your notes feel bad. Hmm? Oh. Oh my goodness, you guys. Wow. Okay. All right. Well, it's not Friday, but I got a story time. But first I'll give you your questions. That's